Today I will be showing you how to reduce alkynes to trans-Alkenes via metal ammonia reduction. Now normally if you want a cis product, you would use H2 and Lindlar's catalyst to reduce the alkene, or if you want to reduce it to an alkane, you would use hydrogen gas and platinum to completely reduce the triple bond. Now today we're going to be looking specifically at how to reduce it to an alkyne just to a trans-alkene with sodium and ammonia. So the first reaction that takes place before anything is done with the triple bond, the NH3 and the sodium react, and this causes an electron to be pulled off of the sodium to produce positively charged sodium and electron, which begins the reaction, the NH3, which is also extremely important for the mechanism to occur. So the first thing that happens is that the electron adds to the alkyne to form a radical anion. So the electron acts as somewhat of a nucleophile and attacks the carbon, which then pushes off 2 pi electrons onto the adjacent carbon to produce a radical anion. So right here you have the electron that attacks on one carbon and it has no charge, and then you have 2 electrons on the adjacent carbon and now it's negatively charged and now it's extremely nucleophilic. And then we move on to the second step of the reaction. So now you have this extremely nucleophilic carbon that can pull off a hydrogen from the ammonia, which causes electrons to be pushed off to the NH3 to the ammonia. So now you have a carbon radical, and now you have the double bond, but you still have a radical, so the reaction isn't done quite yet. So now basically the same thing happens. Another electron adds to this radical carbon. So again, the carbon acts as an electrophile, and the electron acts as the nucleophile to produce another extremely nucleophilic carbon because it has the negative charge. So then the electron pair attacks the hydrogen, which pushes off the electrons onto the ammonia. So now you have the trans product, specifically because the substituent groups are on opposite sides of each other rather than on the same side. And then you just have NH2 negative in solution.